For a few examples, we're actually just going to set up the bounds of integration without evaluating. And that's just so that you can see all these different examples of types of bounds I mentioned to you, to have a little library of references for yourself. And then we'll go back to solving entire problems like this first example after we go through this. So I drew a picture here of a region R. And so somebody might have just shown me this region R and said, set up the integral for some function f of xy. So we'll have a placeholder f of xy, and we want to write this integral that we would actually evaluate. So to do this, what we're going to have to start off with is deciding the order of integration. And so when I showed you these like 3 examples, I said maybe the function is bendy on top and bottom. Then you integrate with respect to y first and use functions of x. If it's bendy on the sides, you integrate with respect to x first in terms of y. And so for our example, it's quote bendy or changing on the top. It's not changing on the left or the right or the bottom. So that tells me that I need my first top bound integral to tell me this function y in terms of x. So I want to integrate up and down with respect to y first, because the thing that changes is on top. And then I'll integrate side to side because that's going to be the constant numbers. And the constant numbers always have to be the last thing I do. Otherwise, I wouldn't get a number for my answer. So I'm going to do with respect to y, up and down, and then with respect to x. And so let's fill in the things I already know. When I'm doing my bounds with respect to x, that's kind of the easy part. So I'm moving from left to right. And my bottom integral for x is the leftmost value. That's 2. And my bottom bound for x is my rightmost value. That's 6. But this part gets a little tricky when we try to do the bounds for y. And actually, I'm going to put these brackets here so it's really easy to tell that those outside ones belong to x. X equals 2, x equals 6. For my y, I need to start from the bottom and go up. So my lower bound for y is the bottommost value. That one actually is easy. It's just y equals 1. Oops. But my topmost value, I need to figure that out. It's this line. So my intercept is at 3. And then in the time it takes me to go over 6, I go up 2. So rise, 5 minus 3. Run, 6 minus 0. So y is equal to 1/3 x plus 3. That's this line right here. So my lower bound, y starts down at 1, but then it goes up to this line we just found, 1/3 x plus 3. And then from here, if somebody told me f of xy, maybe it's x squared plus y squared plus whatever again, I could evaluate this integral and find the answer. But we're stopping here for these examples, so we'll go ahead and move on. This next one, we're doing the same thing. So we're trying to set up this region R so we can evaluate f of xy dA. And this one, we go back to our examples. We say, I want to figure out which part of the curve is bendy and then integrate with respect to that variable first. And this one we actually could do either way. So we could say the top is bendy, or we could say the side is bendy. Since we just did one that follows the dy dx form, I'd like to do one that follows the dx dy form. But let's just make a note here. Either order is okay. And maybe as an exercise to yourself, you could set up the other order. But we're going to try the one that goes dx first and then dy. All right, so my x is that way, but it's the one that has the bendy stuff. So, well, it's okay. We'll do it first. I already drew it. Okay, so my x starts from the leftmost value at x equals 0. And then my rightmost value is this line right here, which I wrote is a circle. So we need to remember the formula for a circle is x squared plus y squared equals r squared. And so we need to figure out how to fill in that top value. What I want is something that tells me the x in terms of y. So I think that we've done a whole lot of solving circle-ish equations in class, with spheres and paraboloids and stuff. And so when we solve x squared plus y squared equals 1 for what the x value is, when we go to this right side of our region R, we get x is the positive square root of 1 minus y squared. And so that's what's going to go on my upper bounds. X starts on the left at 0 and then ends at the right at 1 minus y squared square root of that. And so to finish this out, I just need to give my y bounds. And so y bounds are told up and down. And this part might get a little bit tricky for you. So it's pretty easy to see that at the bottom, we have the flat line, y equals 0. But I think there might be a temptation to say, okay, the top one, I know is square root 1 minus x squared. It ends at that circle right there. But remember, the outside bound always has to be a constant number. And so what we actually do is we just find the highest value that y has to reach on this circle. And so that happens to be this one at the leftmost edge, but it's not always going to be that. So for us, the biggest value y is 1. It was easier here because both sides of the outside variable looked like straight lines. But here, the top part of our region actually looks bendy. But we already accounted for that curve on the inside integral. So when we do our outside integral, we just say, how high up does y go? And the highest y ever goes is up here at 1. And if we had set this up the other way with respect to x, we would have had kind of the same thing, 0 to 1 minus x squared, f of xy dy. And then our x values go from leftmost is 0, and then the furthest right our curve ever goes is right here at 1. And so just so you see that you could set it up either way. But I'm going to put stars by this because that's the way that I wanted to show for now. Can I fit in the third example? Yeah, we'll just go a little over because I want these all in one place. So take a break if you need one. This last one will just take us like 4 more minutes. All right. So here's that last example I showed where your two curves like touch at only one point. And so it's really hard to see which should be like your flat side bound, the one that has numbers on the outside. And I drew here like a zoomed in of the region R just because the first time I drew it, it was kind of skinny. But this is the intersection of the curves y equal x squared and y equal x. And we want to set up our integral. This is another one that we could set up either way we want. So we could kind of say, okay, on the left, there's this line. On the right, there's this curve. And then somehow I figure out how tall y gets. Or you could say at the bottom, there's this curve. At the top, there's this line. And then somehow I figure out how far x goes. And so I'm going to say that we set up the kind that integrates with respect to y first and then with respect to x. And that's just because you all are so used to writing y in terms of x that I think this order will be a bit easier to see at first. So our y bounds always tell us the lower is the bottom of the region R and the upper is the top of the region R. So the bottom of our region is y equal x squared. So I put that there. The top of the region is y equal x. So I put that there. And then to fill in my dx bounds, I have to go from left to right. And remember, just like when we did this previous example, I don't reuse my curves. I don't say, okay, well, I guess I start from x equals y and I go up to x equals square root y because those are the lines I see. I say, I already dealt with the curves. I just need to think about the furthest left and the furthest right that my curve goes. And to do that, we actually have to solve for the intersection of these curves. So I want to know when y equal x hits y equal x squared. And I'm looking for values of x, so I'm going to set the two x parts equal. I'm going to say, when is x equal to x squared? So if you wanted to, you could reorder this. 0 equals x squared minus x. So we've got x times x minus 1. And so that intersection happens at x equals 0 and at x equals 1. I drew that kind of bad to start. Sorry, they're down here at x equals 0. And so the furthest left my region goes right here is the point 0, 0. And the furthest right my region goes is when x equals 1, which happens to be y equals 1 as well. And so my x bounds go from 0 to 1. Real quick, since we're here, I'm going to set it up the other way as well. All right, now I want to fill this in, integrating with respect to x first and then y. So let's draw our little contact lens shape again. So my top line was y equals x. So that's the line x equals y. And my bottom line was y equal x squared. So that's x equals square root y. And so when I integrate with respect to x, I go left to right. So my leftmost curve is x equals y. So I start down at y. And then my rightmost curve is x equals square root y. So I go all the way up to square root y. And that's true everywhere on the contact lens. And I just wanted to show this because it's a little non-intuitive. The bottom is x squared and the top is x, but it's flipped when you go from left to right. The quote bottom, the leftmost, is the y equals x line, and the top for x, or the rightmost value, is the y equals x squared, x equals square root y line. And then my bounds for y, I could solve the exact same way. I want to know when x equals y hits x equals square root y. So I'm going to set my y values equal and solve for y. So I've got y equals square root y when. So I'm going to square everything, I guess. Y squared equals y. And so this one, maybe I'm the kind of person who doesn't factor stuff. I say, I guess, and check. Y equals 0 for sure makes this true. And then 1 is the same as 1 squared. Y must be 1. You also could have set up these equations this way if that's what makes you happier. But this tells me that the bottom value, the y is at, is 0, and its top value is, wow, that's a weird place for that dead zone to be today, 1. So up here is 1, down here is 0. And again, we didn't repeat the curves. We just thought about the lowest possible value and the highest possible value, and those became our outside bounds. Just like we looked at the furthest left and furthest right for our outside bounds. Those always have to be numbers. I'm sorry this video was a little longer than usual. I just wanted you to have all 3 of these examples in one place. And so hopefully now you'll have a reference to go back to every time you hit one of these 3 types of regions to set up.